One of the most basic shapes is a line. So how do we write down the equations for a line or line segment in 3D space? First, we'll pick a point P on the line. Then any other point on the line you get by traveling from P in a specific direction. So if V is a vector parallel to L, then L is defined by the equation P plus TV, where T ranges over all real numbers. We call this the vector form of the equation. Beware that P and L of T are points, whereas V is a vector. If we unpack this equation, that's equivalent to 3 linear equations for the coordinates x, y, and z respectively. Now, P and V are not uniquely determined by the line. We can pick any point on the line for P, and we can replace V with any scalar multiple of V, and we get the same line. But we often encounter a specific version of this situation where there is a preferred choice for P and V. Namely, if we have another point Q, and we want to parameterize the line segment between these points, or specifically the line segment going from P to Q. In this case, we do take P to be the starting point, and for our vector, we take Q minus P. And here we just let T go between 0 and 1. So here, Q minus P means the vector from P to Q. So the textbook writes this as over arrow PQ. So that's another notation for the same thing. Anyway, so there's 2 ways to think about this equation. Like this, it's start at P and then add T times the displacement from P to Q. But we can also write this as 1 minus T times P plus T times Q. So from here, you see right away that when you take 0, you get P. When you take T equals 1, you get Q. And in general, it's a sort of a weighted average of the 2 points. So they're equivalent. I just find this version a little more helpful for remembering the equation. So here's an example. Let's say we're asked to parameterize the line parallel to the vector 2i minus j plus k, and going through the point -1, -1, 0. So we could write this in the vector form as -1, -1, 0 plus t times the vector 2, -1, 1, with t between negative infinity and positive infinity, or just t and r would be another way to write this. And we could also expand this out into the individual components. So we would get x equals 1 or -1 plus 2t, y equals -1 minus t, and z equals t. Again, with the domain of t being all real numbers. So either of these forms would be an acceptable answer. Next, say we're asked to parameterize the line segment joining the points 1, -1, 0, and -1, 3, 2. So first we'll find the vector Q minus P. This will be -2, 4, 2. And so the form of the line segment going from P to Q minus P will be 1, -1, 0 plus t times -2, 4, 2, or if you prefer, this will be 1 minus 2t, -1 plus 4t, and 2t. In either case, the domain of t is now just between 0 and 1, or another notation for that is this closed interval, 0, 1.